Catherine Stevens from the American Chemical Society. Welcome to this news briefing from ACS Spring 2021. We're joined today by Dr. Elizabeth Ambrose from the University of Minnesota. They're studying, and Connor McDermott from the University of Minnesota. They're studying Paleopharmaceuticals from Baltic amber that might fight drug-resistant infections. Dr. Ambrose?
Hello, thank you so much for that introduction. So we're really happy to be here with everyone today. I'm Elizabeth Ambrose. I'm an associate professor of medicinal chemistry at the University of Minnesota, and I'm joined by my grad student, Connor McDermott, also from the University of Minnesota. So I think that we might be having volume issues here. Let me try. Does that help? Okay. So I think you guys were going to bring up the slide. All right. Am I audible, everyone? Okay. Yeah, so my group actually focused on several areas of research. What we're going to share with you today is our recent research on paleopharmaceuticals, so specifically potential therapeutics from fossil material. So we might want to ask, why do we want to learn drugs in fossils? Well, we know that we are in desperate need of new drug scaffolds in key areas. And so I'm mentioning 3 of these today. That includes pain, inflammation, and most notably infectious disease. So fossils can actually be an unexpected source of new chemical matter. And so the reason for that is that the compound that you obtain from fossils will undergone biotransformation over millions of years. And so those very, very gradual reactions, series of reactions, can lead to novel structures that we haven't seen. And also these compounds are from species which are now extinct. So their biochemical pathways can vary from ones that we see in modern species. So why get Baltic amber? Well, it really is a treasure trove of potential new chemical matter, potential drug scaffolds. And so it's been used for hundreds, maybe even thousands of years in Baltic traditional medicine. And there has, however, never been a comprehensive study of bioactive compounds in Baltic amber extract. And so that medicinal chemistry perspective is we've brought to this project. And in our research, we have identified a compound, Baltic amber, that has turned out to be strongly active against methicillin-resistant Staph aureus. So we're very excited about that. And my graduate student, Connor McDermott, is going to be presenting our results at the upcoming American Chemical Society. So Connor, did you have anything to add, Ray?
I don't think I have anything to add right away, but yeah, just very exciting research on this kind of new area of paleopharmaceuticals. So therapeutics from fossilized materials. And it's not something that's been very investigated. And so we're really excited to kind of be trailblazers in this kind of new area of types of therapeutics. So yeah.
Thanks so much, Con. We'll be happy to take any questions.
Are there any questions from viewers? Please state your name and affiliation in the chat window when you ask your question. I have one question for you to start us off. How does amber form?
So amber actually forms for millions of years. This actually is a small beaker of Baltic amber from Lithuania, which I obtained when I was there last. It actually forms millions of years as a fossilization process. So actually fossilized resin from an extinct species of pine, actually from several species of pine, which are in the Cytopithecus species. And so Connor can maybe tell us more about that.
Sure. So the process of getting to amber, basically, amber is fossilized tree resin, and it's a substance that plants secrete, and the resin is specifically used to kind of fight off bacterial infections and to fight off any sort of insects that might prey on the plant. And so that is exuded, and it slowly kind of sloughs off of the plant, and eventually can be found in kind of sedimentary layers, and that's where the fossilization process really occurs. And that happens over millions of years, and basically causes the substance to harden and become that solid material that we know as amber today.
Great. Have there been any previous studies that test Baltic amber's medicinal properties, or is this entirely from folk medicine?
Yes, there have been very few public studies having to do with the medicinal properties of Baltic amber. There were some studies that carried out some time ago in the Baltic countries. I believe there was one in Latvia that was done. But there has never been anywhere a comprehensive medicinal chemistry analysis of the constituents of Baltic amber and the individual pathways which they might work. We also are kind of trailblazing in the sense of identifying new potential biochemical pathways that are involved in things like pain and infectious disease.
Is Baltic amber unique from amber from other parts of the world?
Yeah, that's a very good question. Baltic amber actually has used most often folk medicine through the years. So its reputation of being the type of amber that has the greatest number of medicinal properties. Now, we know that for sure at this point in time. There's a lot more work left to be done. But there have been several paleontology-based studies focusing on various differences in Baltic amber samples from different countries, from different parts of the world, and they do differ significantly. But short answer that we're not sure at this point in time. We need to do a lot more work in that area.
Great. So how did you collect the amber used in the study?
Well, we actually had a number of sources of Baltic amber. Last couple of times that I traveled to Lithuania to visit my family there, I was able to collect samples from the natural environment, and then also from various suppliers. We also had some samples here that we obtained previously. We have some samples also from Latvia. In short, you can actually purchase them, so they are commercially available. But it's very enjoyable to actually go to the Baltic countries and to be able to find it in this location. So, for example, in forests, on the beach, you can find amber. It washes up very commonly, actually, on the shores of the Baltic.
So you use a tabletop jar rolling mill. How long does that take to crush the pebbles of amber?
Sure. All right.
Well, I can probably field this with the experimental work. So yeah, the entire process, that takes about 3 hours. And that takes the amber that Dr. Ambrose showed on the screen. It takes that to a fairly semi-fine powder. And so, yeah, it takes about 3 hours for, I think the amount we used was like 25 grams of Baltic amber. So, and yeah, creates that semi-fine powder that we then use directly into the extraction process.
So have the 3 compounds you identified in Baltic amber been previously tested as antibiotics?
Short answer, yes and no. The compounds that we tested, that we actually sent away tested in various types of bacterial assays. Those three compounds are actually commercially available. The reason why I looked at those is because it's very difficult to separate out all the different abiotic acid analogs that are in the amber extract. They're very, very similar to each other. We don't know which one or are active. So we look at some general starting points, to design potential drugs. These could potentially serve as drug scaffolds. Yes, three are commercially available. I believe that abiotic acid was met previously. It was about maybe 10, 15 years ago. I don't know, Connor, you can probably provide some more information on this, but investigation hadn't proceeded very far, I believe. And I don't know of research that has looked into the medicinal chemistry process of the other two. Maybe Connor has more info on that.
Sure. So there are studies on those parent structures that we did get that are commercially available. But the interest that we have is that the various analogs that we've identified in Baltic amber, those necessarily have not been studied in terms of their medicinal properties. So there are various studies on like dihydroabiotic acid has some even anti-cancer properties, and abiotic acid and its analogs have been shown in various types of antibacterial and other various applications. And the reason why we were very interested in those specific compounds and those structures is because the known kind of uses of Baltic amber in terms of its folk medicine properties match so it's been used as an anti-cancer, immune boosting, wound healing, antibacterial kind of therapeutic, the Baltic amber itself. So these compounds that we found have some initial studies to show that they kind of match those specific therapeutic applications. And so we're interested to see how our analogs that haven't been tested, if they are better or worse than these compounds that have been studied already.
Yeah, and if I can add maybe just a couple of small sentences to that. I want to emphasize again that there are hundreds, maybe even thousands of abiotic acid analogs in the extracts Connor has found. And they're structurally very similar, difficult to separate out, but it's a true treasure trove of abiotic acid analogs and abiotates that we haven't seen anywhere else. It's pretty unique.
Great. So I think I have one last question for you. How did you test the compound's activities against bacteria?
Okay, so yeah, those compounds we actually sent away Eurobins. We had them run all three compounds, I believe, against their infectious disease panel. And so that's where the results were.
So one more for you before we wrap up. What take-home message about this research do you want to leave with viewers?
I think we can both try that. I'll start out and then I'll hand it over to Connor. Take-home message is that fossils are a really, really fascinating place to look for new chemical matter and for new starting structures. So Baltic amber is really the beginning, and compounds that we're looking at in Baltic amber are really the beginning of that. So there's a lot more work to be done, but we really just start looking at Paleopharmaceuticals, some of these unexpected sources, because we're in dire need of new scaffolds for some key disease modalities.
And yeah, to add on to that, just in terms of the work that we've done with Baltic amber, I think the big thing that we've been able to do in terms of our research is extract and identify various compounds that have the potential to be therapeutics for things like bacterial infections, specifically drug-resistant bacterial infections. So we're really excited about the promise that already Baltic amber holds in terms of treating hard-to-treat diseases.
Thank you both. The archived version of the session will soon be posted at www.acs.org/ACS Spring 2021 conferences. Please join us for our next press conference tomorrow at 10 a.m. Eastern. Thank you.
Thanks for having us.